Alright, so today we're going to be covering functions. Now, functions are a very important part in graphing, and mastering function notation and functions and shit is a very important aspect of life or something. Anyway, so we're just going to jump right into it with the very basics. So as you can see here, I've got my first function here, which is just y equals 1. So in other words, our output's just always 1 no matter what. Would you even call this a function? I don't fucking know. Anyway, moving on quickly to something I'd actually call a function, y equals x. Basically, we're just taking an input value, which is just x, the x-axis, how far it is left or right, and making that the output value. Pretty simple stuff. We can actually incorporate a constant value like we did with the top thing here, with the y equals x, to get ourselves a very nice and fresh combination, I guess, of shit, and I don't know, it makes a completely new output, or set of outputs, I suppose, to be more accurate. So yeah, that's pretty cool. And there are plenty of ways you can use an input to make fancy different outputs, and you can get all sorts of different things, as you can see with all these different examples. Yeah, basically functions are cool, and gotta know how to use them, and they can be used in a lot of different ways. Like you can draw some art shit, or you could do like a fancy gradient rather than just like a linear gradient. I honestly can't think of any other examples off the top of my head, so we're just gonna move on. Function notation. Now, function notation is basically where we have like a letter, and then in brackets our variable. You can actually do two variables, which is something I haven't explained here. I might get into just as soon as we finish explaining quickly how function notation works, right? So we have like f of x is equal to, negative x over 3 plus 2. We get this function here, right? That's pretty cool. But what if, the beauty of using function notation here is you can use it in other functions, so quite quickly, right? As you see, we got this function here, this red one, and that incorporates this top function here. So another way of writing the bottom one here is just to replace these, and I think that they change it. Oh yeah, right. You want to put this in brackets just as a heads up. Yeah, there you go. So if I make that like f of x, there you go. So yeah, it's something you can do. It's quite niche and convenient. So yeah, that's the big reason as to why you want to do function notation. You can also shift, as you can see. That is, you can shift it back and forth. And constant obviously just shifts it up and down, as it has previously. And so yeah, that's basically function notation. Pretty cool. Let's see, I haven't really used function notation with multiple variables that much, but you could say like x squared plus y squared as well, right? And then if I do d3 and 4, I get 25. If I want to go sqrt x squared plus y squared. As you can see, it's a Pythagoras thing. Look, I've just done a quick function to, find yourself the hypotenuse in a, right angle triangle. And it will work for any sort of values, right? And that's surd too. See, they look the same, right? It just rounds it, I don't know, guesses it? Not guess. It estimates it, that's the word, yeah. And so, you can use those sort of, two input variable functions and get yourself an output, which is pretty cool. I mean, for the lols, why don't we try going like, A, X, Y, and Z. I wonder if this will work, right? And then we can just go like X, Y, Z to be real quick. Now if I go A, 1, 2, like that, we're going to get 1, and 2, 3, you get 6. Ooh, look at that. Now isn't that grank? Ooh, this one's 7, we'll do that. And so yeah, you can use all sorts of different shit with functions, different amount of input values to get yourself an output. The key thing though is you only get one output. A function, well sorry, something is not a function if it does something along the lines of like this. It's called the vertical line test. It's pretty simple to do. Some people say to draw an actual line and check, but I think that's dumb. Just sort of look visually, can you see any 2 points? Like just imagine this green line here and just move it across the graph in your mind and just see, oh, are there multiple y values or multiple intersection points of this green line? And if there are, it is not a function. And also you should probably check multiple places if you really need to, because if it just intersects like there, like tangent, like this one little spot, hey, it might look like a function if you're an idiot. Just don't let that happen, just be careful, okay? I'm looking out for you here. So yeah, anyway, functions. Alright, so personally I think the way decimal should work is, you know, your main sort of arteries of things you're making, you know, should be in parametric, because that is the OG. But if you want to do a bunch of fancy shit, you know, like if you want to really get complicated with your manipulations, you should really store them in functions, and then, you know, just chuck them in to your, you know, graphs as you feel like, you know. And you know, I had no idea what this would look like. I just did it randomly, and there you go, you know. How far back does it go? Ooh. Oh, look at that, that's pretty nice, it's pretty cool, pretty slick. Oh, okay, see? And you make some pretty nice stuff, which is why we should all do a bit of maths. Anyway, that's about it for this. Moral of the story is learn function notation and use them in parametrics. I might make a video on, you know, parametrics, because they're better in like every way, but you know, functions do have the perks, which I've only like just learnt about really. I was like, oh, you can use them for like this and this and this. Up until then I was just using parametrics for everything, but no, functions are pretty cool, check them out. Yeah, shout out to functions, and yeah, see ya.